Hi everyone. I hope we are live now. I want to wish a warm welcome to everyone to another Memgraph community call. So today I'm joined by the NASA People Analytics team. So I have David, Madison, and Catherine with me here. And they will be introducing themselves shortly and walking us through their work. So I won't do that for them. But let me give you a short background story on how we met. So I first met David actually through the Memgraph community some time ago. And we had a couple of discussions about graphs, Memgraph, potential use cases. And I was really excited when I first heard about this project which they will be presenting today, talking about people knowledge graph. And I think it will be a really nice session for everyone, especially those who are looking to understand how to store and work with this kind of data in a graph database in general as well. Also they will touch up on their plans to enhance knowledge graph using LLMs, and they will show us something with that. I'm looking forward to the demo. So Madison, let the demo go. Gods be with you, and Catherine. I wish you all the luck with that. And I would like to, of course, thank David, Madison, and Catherine for putting this presentation together. And I'm looking forward to hearing all about what you built, what's ahead, and I hope that everyone else finds it as valuable also. So with that, I'll hand it over to David, who will start, and then to Madison and Catherine, and good luck with your presentation.
Thank you, Catherine. I appreciate it. First of all, thank you and Memgraph for allowing us this opportunity to showcase some of the work we've been doing in the graph database space over the years. For all those of y'all out there, thank you for joining us. My name is David Mesa. I am the head of analytics for human capital at NASA, as well as the branch chief for people analytics. Started working in the graph database field about 10 years ago, doing a lot of different types of use cases, from looking through documents, doing some type of search. Eventually moved over into people analytics about 5 years ago, where we started looking at skills analysis in this use case that we're going to showcase today, more around how we're utilizing graphs, not only looking for information and looking for individuals throughout our organization, as well as how we're able to incorporate some of the latest technologies around large language models into that. It's still a lot of work in development, but we're really excited what we can do with this. We're really excited to what we've been able to do with the Memgraph database system. It's really provided us with a lot of good opportunities. So I won't going to leave it really to Madison and Catherine to showcase the work we're doing here. They've been great in picking up the work as we started this several years ago. But they're going to showcase some of the things we've done, and I'll allow them to introduce themselves at this point. Maddie?
Awesome. We're going to get into intros in just a second, but I'm going to share my screen real quick so we can get our slides moving, and then hopefully later also get into some of our demo stuff. So just confirmation real quick. You guys can see everything?
Yeah.
Awesome. All right. So we'll get into introductions first, but this is kind of a run of show today that we're going to get through. We're going to talk about why we use graph databases in the first place to model our people data, what it allows us to do. We'll go through kind of how we set up Memgraph in our environment, how we got our data in there, how we modeled it and structured it, what that kind of final graph schema looks like. And then we're going to dive into what the queries are that we can actually run then on that graph schema and data, as well as demo a little bit of a very in development but functional RAG piece that builds off of the graph database foundation. Of course, there's a lot of future work to do on that, so that's what we're going to wrap up with, and then we'll get to questions at the end. So with that, we have some introduction slides. I'm going to dive in and then hand it off to Catherine to do hers as well. So I'm Madison Osterman. I am a data scientist and data engineer on the people analytics team. I've been working at NASA now for nearly 4 years. I got a bachelor's degree in computer science, and I'm currently doing a master's in analytics. So rounding out my programming experience with more of the statistical modeling end of things. I live in DC, have a cat dog, been married for a couple years now as well.
Hi, everybody. Good morning. Just testing. Can you hear me? Because I'm having
Yeah.
some. Okay, perfect. It's so great to be here with everybody. My name's Catherine, and I'm a data scientist on this team. Previously, before coming to this team, I pursued a degree in industrial engineering and engineering management from the School of Mines. I have an MBA where my background specializes in strategic risk and responsibility and data analytics. And I've been able to be a part of this fantastic team since 2023. Outside of my professional experience, some hobbies that I enjoy, I haven't lived abroad and I'm not a pet parent yet, but I do enjoy public speaking and mentoring people, specifically young professionals and college students in STEM. I really enjoy hiking, and one of my favorite hobbies is art history.
Awesome. So, to get into the thick of things, so we're going to start off with why we used a people graph in the first place to represent our data. So, a lot of our people data is stored in a relational way, it's in a data warehouse, but that structure doesn't really lend itself to the analysis that we think could be possible around skill analysis, looking at projects, how these pieces across our agency connect and can be integrated with things like supply and demand modeling, other workforce planning applications, those types of things. So modeling this information we've experimented with in a graph format, and this we found has allowed us not only to see the data in just a more intuitive way, but it also enables us to start to see the possible ways of leveraging the power of graphs, like with community detection or clustering. So as you can see here, I have an example on myself of how I'm connected to my organization. And while I didn't explicitly put it in here, at least my imagination goes wild on this, because from the organization, I'm not the only employee connected to that. So now you can start to look at all the other employees connected to that organization or center. When it comes to skills, this is extremely powerful because if you think about skills in a relational data structure, you're kind of you're kind of stifled with your structure. You would either have to have your employee and like a single row and column with the skills listed within that, which you then have to get into processing, iterating through in your code, or you would have to have multiple different rows for each skill. And that just isn't quite as intuitive as the structure. You don't connect the dots of, oh, well, we could do a skill gap analysis or look at shared skills between things or cluster skills into topics. So we've found that this is really a good way to model this data. We don't have a skill management system. I want to note, while I do have some skills listed here, we don't have a skill management system or really any true way to connect an individual to their discrete skills. So one of the approaches we've taken in the past is actually inferring someone's skills via their occupation series, which is kind of what you're saying here. It entails having an occupation series, and entails a set of assumed competencies and skills. So we're saying sort of an ability to impute data through hops in a graph. However, we have learned in the past, trying to do this, trying to grow this pilot into something more, that approximating skills really isn't quite good enough. So we landed in the past at needing to process unstructured data like resumes, project descriptions, those sorts of things to get this data to be more useful. And that was work done pre-large language models, pre-fall 2021, when ChatGPT was first released. So pre this, our approach to processing unstructured text and extracting information was using different NLP models. This is an example of like custom named entity recognition on a specific question. In a like kind of a text to cipher pipeline is what we were testing out with this. We also use the same custom named entity recognition testing on structured text, like projects, descriptions, and resumes. So we did make some decent progress on this. With any cool R&D work, sometimes unfortunately gets put on pause to prioritize some other work. So we actually put this kind of on hold in 2021. Of course, later that year, enter LLMs to the development scene and graph applications. We will elaborate on this more later, but we're now able to, instead of having to go down a very specific route of doing custom named identity recognition and having your curated or tagged, manually validated testing data sets and training data sets, we can now use large language models to do a lot of this information extraction, and also to retrieve that information, as we know in RAG. And so this is, since these earlier days of working on graph analytics and processing unstructured tests, it's really helped us make some significant headway in leveraging our people graph for answering questions in a way that would have just required significantly more work before. So we'll get into how we actually set up Memgraph in our environment. We do have it deployed in the cloud, so I'll detail that, as well as a little bit about the data we've prepared in the graph and what it enables us to do as far as queries and RAG goes. So this is kind of an overview diagram of how we have deployed Memgraph in our environment. We have more pieces than this, but I did want to mention a few of these. So we deployed Memgraph with Mage using a Docker container on an EC2 server in our AWS commercial environment. That is part of an agency infrastructure we have. We do have an enterprise license in Memgraph, so we did this both in our dev and our prod environments, and having the ability to have multiple databases in Memgraph has been pretty useful. We actually created a separate one, as I'll get into, for the specific presentation, just to keep our data separate, protect PII. So that's been really nice to have. We worked with the Memgraph team. They gave us kind of a pre-feature request to get some of our data from our S3 bucket into the database. So we run a Python script that can pull that data out of, I think we have Parquet files, CSV, the like, and ingest that into Memgraph. So that's been helpful. We don't have a full automated scheduled pipeline yet, but at some point we will want to integrate this as the graph analytics grow and being adopted. So we want to make sure that that can integrate seamlessly with our infrastructure, which it currently is right on its way to doing. I also want to mention we do have an Ollama server deployed very similarly to Memgraph through a Docker container on an EC2 server that can connect its own environment. So as long as a server can connect to both of these, it can run. So sometimes I have them talk right between each other. Sometimes I can call it from my local laptop if I'm working on development locally. But I want to mention that because obviously a large language model is a big component of RAG. We choose to use Ollama because it's open source and free, and it also being able to be deployed on our servers means that our data does not get sent external to our resources, which is important because that's a requirement for the data we handle. We cannot send it external to the agency. So that is a glimpse into our infrastructure. I'm sure this is just one of the many, many ways to do it, but this is just what happened to work for us. So as far as actually getting the data into Memgraph, I mentioned the S3 bucket and how we import data into it. Just from S3, we use Python and the GQL Alchemy package, Memgraph portion of that, to just run Cypher queries through it. And that's how we actually import the data into the database. Now we have a few different types of data that we've imported. One is people data from our personal data warehouse. We have some project data coming in from an AI use case registry that the Office of the Chief Artificial Intelligence Officer put together, the Chief AI Officer put together. And then we also have some skill data that we extracted from resumes. So as far as the people data goes, for this presentation, we did take out some sensitive information that's not super pertinent to this application anyway. I want to specifically call out that in this demo, when we show people, you will see names, but they're fake names. I've substituted in real names for some synthetic data to protect PII and taken out anything else that is borderline sensitive. So it is the real employee data and the relationships between the organizations and the skills, those sorts of things. You just can't tell who's who. So I want to clarify that just to make sure we have that base covered. But with the project data, moving on to the project data, we want to get the similarity between project descriptions in addition just to having the project data connected to the employee. To just help answer questions with basic Cypher queries. I think this type of enrichment, though, in today's world, when we're having more RAG applied to graph databases, sometimes we tend to overlook enriching the graph data well enough to get it to be most useful for our application. So I did want to call that out, of even though we have some RAG capabilities that allow us to look at similar projects through, the embeddings or vector search, those sorts of things, we still like to have some of that relationship data enriching the graph to make it even more useful. The last piece of data, as I mentioned, was the skill extraction. It is an entire presentation in and of itself. We actually have an intern working on this separately than this project mainly. So I won't get into the specifics right now. Happy to take questions on it at the end. The main thing to know about how we extract skills from resumes is we take a few resumes from our team. We sent a prompt and those contents to an Olama model. Again, that data is not being sent externally. And then we process the output. We've taken a few different methods and approaches to this, and evaluating accuracy has been a big focus for us recently. But the output is the extracted skills from those resumes. What we end up getting is this people graph schema. I know this is a little small potentially, so I apologize. I couldn't fit it any more zoomed in on here, so you may have to zoom in a little bit on your screen. But this is what the graph schema ends up looking like. You see that in addition to having the distinct labels on each node, we also added entity as a label on all nodes. This is part of the data preparation for RAG that I'll talk about later. But really, as you can see in this, all of the people data centers around the employee. At the bottom, we can see the connections to position-related data, like their occupation. So that's their position class code, occupational series, and those categories or hierarchies that those belong to. Moving left and upward in this visual, we see that we have their pay plan or grade. That can be an indication of expertise level or seniority level, depending. So that's a nice piece of data on the employee to leverage and some analysis. Then we start to get into the context of an employee at the agency. So we have their organization, we call it a MISO, it's a Mission Support Enterprise Organization or office, and then a center. Those are oftentimes aspects where we're asked to report employees out by, how many people at the center are doing XYZ, that kind of thing. Now, as you can see at the top, this is where we start to see the connection to the project data that I mentioned. So not only can projects be registered by employees in this AI data registry I mentioned, but they can also be associated with centers. So you can't see it from the graph schema here, but projects each have the property of a description that includes really good unstructured text about what the project entails. So that's what we are using for the most part to analyze projects when we look at the embeddings and the RAG piece. You do see the similarity relationship I mentioned before, though. It's a self-directed relationship back to that project node. Moving on, going down to the right of the project section, we do have some information about the employee's education, so their level of education, the university they attended, and what they studied. And then finally, their extracted skill. We did not get into classifying the types of skills yet, so we just generically called it extracted skill for now. And these are, as you would guess, the skills extracted from the employee resumes. So hopefully this gives kind of a good foundation of what our problem was, why graphs work for it, how we set Memgraph up in our environment, and then now what data we're dealing with. So as we get into the queries and demo, hopefully that gives you a good foundation so you can kind of keep up with the problems we're thinking about and the way we're looking at data to answer those questions. So I'm going to go ahead, hand it over to Catherine because we have some queries to show.
Okay. Sorry, I'm having some technical difficulties hearing Madison, so I'm going to jump in. Now that Madison's done such a fantastic job of setting up, one, how we began to understand our people graph, how we understood what data we were going to need for that, and three, how we actually set it up, I get the pleasure of talking to you guys about what we've been actually doing with the data now that it's ready for some analysis. Next slide. Perfect. So when we started this project, there was a multitude of avenues that we could have gone down with what questions we wanted to narrow in on and how exactly we wanted to study this people graph and use this people graph. We ultimately landed on 3 categories to start with of questions that we were going to pursue. 1, SME finder questions. These are questions that help us understand the makeup of the individuals of the workforce. Who across the agency possesses what skills, how those skills interact, where we might have some gaps in our skills, specific technical domains, systems, or even mission critical capabilities. Our goal with these questions is to understand how we can improve and accelerate collaboration maybe some problem-solving techniques, knowledge transfer, and how we store expertise so we, in the future, have a better understanding of who has what skill and how they could make an impact on projects. 2, leadership report out descriptive questions. These are high-level, mostly metric-based driven questions intended to give leadership a different audience than maybe the SME Finder questions would be, visibility into workforce composition, capability distribution, and organizational dynamics. And then 3, project overlap questions. Pretty straightforward, but these are questions where we want to understand what are areas of shared expertise. Do we have work being duplicated across centers? Is there areas and opportunity for cross-center collaboration or even just cross-team collaboration so we can better utilize the workforce that we currently have? Now we're going to switch out of our slide deck and we actually are going to give you guys the opportunity to see 2 or 3 queries from each of these categories that I just discussed. And we're going to give you guys a little sneak peek of just exactly how we're using them, what we're doing with the data, that we are able to make an impact on our team currently. So the first query that we are looking at, Madison, I think she ran it already, is specifically looking at who has the most experience specifically to the AI/ML category deep learning project. Now, AI/ML category deep learning is just a placeholder. It's just an example here, an interesting analysis. We can see on our team, which employees are working, how many projects that they're touching at a time. So you can begin to see people with higher amounts of opportunity to work on these projects naturally are going to have more expertise. And so if you're looking for a subject matter expert, okay, well, you can begin to analyze, I need somebody on our team. I'm going to pick the first person up on that list. Okay, does that person have the ability to step in on this project at this time? Do they have the bandwidth? No. Okay, we have, X amount, 14 plus right there on the screen of opportunities to call up and pull in somebody we know has verified expertise for this area. Now you can broaden this search and not have a specific AI/ML category selected. You could specify it even more by narrowing down, do we have people working on similar projects, which we're actually going to get to in a second. So our second query for our SME Finder categories, we're pairing the natural language question, which employees have worked on projects that span multiple distinct AI/ML categories, what we kind of hinted at on the last query, and how many categories have they engaged with. So what you can begin to see is the relationship between employee to project, and then the relationship expanded off of that from project to AI/ML category. You're able to look at who is touching multiple projects or who is touching multiple AI/ML categories, and how does their backhand experience support any sort of future work we might be pulling them in for. So then our third query is pairing the natural language question. Who are the employees working on multiple highly similar projects, indicating a deep expertise in a particular area of technology? So again, we're exploring that relationship between employee to project and then projects similar. We're looking at a cosine similarity greater than 0.9. We're comparing all of the cosine similarities for all of the employees. And from there, we're able to create a distinct list of the fake, for this purpose of the project, this fake employee, how many projects that they've worked on with what those unique projects are. And we can guarantee that they're greater than a 0.9 cosine of similarity, which a 1-for-1 is almost identical similarity. So then our next query that we're looking at, we're pairing the natural language question, how many projects, this is now moving into leadership report out descriptive questions. So remember, these are a little bit more metric based. These are a little bit more high level. These are intended that if you were somebody who needed a quick answer about the workforce, we could give you that. So we're looking at how many projects are associated in each AI/ML category at each center. So a leadership might be wondering, I want to know who, I want to know what, and I want to know where. And this question can help answer that. So when we run that, we get a list of what center. So scrolling down, you see AIMS, you see GRC, you see HQ. We see what category, and we see how many projects are associated with that category. So you understand, okay, well, HQ does this particular AI/ML category more than anybody else. AIMS does 2 different AI/ML categories, and they're the front leaders. So you start to begin to see who is the leader of what research and where. So then we are looking at how many projects are employees from each MSCO area involved in. So this is a different area we are looking at now. And so we're exploring the relationship between MSCOs and employees to the projects that they're registering that they're working on. We're understanding of the MSCOs, so Office of Protective Services, Office of Chief Information Officer, Office of Chief Human Capital Officer. How many projects are they all working on at one time? What is their bandwidth? Who's overworked? Who has the opportunity for collaboration, or the opportunity to expand? And then we have how many employees from each OPM series are working on AIML projects. So for this question, we have the opportunity to explore occupational series and its relationship with the employee's relationship with project, which has been a pretty prominent data point for the purpose of this presentation. And we're able to look at, okay, we see the OPM series. We have 1301, 0861, 1330. Then we understand what those OPM series are. So we understand we're looking at general physical science. We're looking at aerospace engineering. We're looking at astronomy and space science. And then we're looking at, okay, who is working on how many projects? And from here, you can even expand this query. You can understand of those projects, what is the AIML category? Who per center are we seeing work on these? And then we move into project overlap queries. And so the first question that was on our minds was, do centers have similar project work going on? Meaning, is there overlap? And so with this, we're able to actually compare projects across different AIML categories across different centers. And so we evaluate those relationships. We're pulling in those cosine similarities again, because we want to make sure we're actually looking at projects that are similar. And from there, we're able to pull out a list of two projects, project one, project two. So two totally different things, where they're located. You can pull the employees' names. We chose not to for a return on this query. And then how similar are they? So we're looking at an R cosine of similarity of 1. So that's similar, very similar. So from there, we were able to explore which pairs of projects. And again, we used a placeholder for an AIML category. We used generative AI for this final query. And we want to know, of the generative AI projects, which are 70% similar. And so with this query, we're able to see that there's only 2 generative AI projects across any center at this time that is 70% or more similar. So not much duplicated work going on. We're able to see what exactly those projects are. If you're looking at the output, they look very similar. Those first 2 are, they both start with like Nova 2.0, but if you keep reading the titles, they are different. And we're able to see these 2 projects have almost a our cosine similarity, and the other one just has barely over a 70%. So we're beginning to create a list of data points where we know, hey, if we get stuck on a project, we could call the team working on this project that's doing something very similar to us, that has a different unique use case, and we can see what they're using and understand, hey, is this an opportunity for collaboration? Is this an opportunity where we can pull in some expertise here from another area and improve this project better for everybody? So now that we've had the opportunity to explore just like a handful of queries that we've been looking at as we begin to build out this people graph and the opportunities we have to use it, I'm now going to hand it back over to Madison, and she's going to get the opportunity to kind of explain to you the next step. So where manual natural language questions meets manual querying, we are beginning to utilize RAG for a more chatbot and a large language model experience.
Great, thanks, Catherine. And I know as we were going through some of these, I would have to say our RAG is not good enough yet where we can actually translate these one-to-one. We did try on a couple things, but we still have a lot of development to do. I also wanted to comment, I don't want to gloss over the fact that our data does need some improvement. I think that that's a point in graph databases that is often overlooked of really vetting through. It's a sign to me, I see a cosine similarity of 1 here, meaning that these project descriptions, which really what it's coming down to is the embeddings of those project descriptions, are coming back as 100% similar, which flags something to me going, oh, we need to double check that process and making sure that our data is actually good. And there's a couple points in here where that's the case of you really need that subject matter expertise to go over this at first before you expand it to RAG. So I wanted to mention that while we're here because it's not our intention to go, oh, we got the data good enough, we're going to move on to the new exciting RAG piece. The RAG piece was something that we wanted to at least test out to see if it had promise, but it's definitely top of mind for us to actually go back and check in on this data and make sure that all of our processes and the quality of the data underlying these answers to questions are at the highest quality it can be before we move on. So wanted to mention that before we get back into things. But thank you, Catherine, for going over those queries. Yeah, I'm going to be talking about how we're thinking about doing RAG on top of this. So to start off with, kind of two different pieces of RAG, so retrieval augmented generation, the preparation piece and the actual process piece. So with RAG against a graph database, there's particular preparation you have to do. I wanted to call out two resources that I found very useful when I was testing out some stuff. So one was a tutorial on vector search that had been put together by Memgraph that talks through how you create the embeddings using your metric of whatever. We chose cosine similarity. Still really need to test the other options out and see if we can achieve better results with a different metric. But it goes over vector search indices and how to leverage those against embeddings to kind of do an advanced fuzzy search kind of thing against the graph. But then larger, that builds a foundation for actually establishing a RAG process. So knowing how you actually use the embeddings to create a vector search index that your RAG process can reference and be built upon. So I wanted to call that out here. What we have used RAG for. So you guys saw how we've used large language models on the kind of pre-graph end to get information extracted from unstructured text into discrete nodes, like those extracted skills. And while getting some of that information back with Cypher queries is really appropriate for some situations, like Catherine showed, a more accessible way to interact with the graph data is via a chatbot or some sort of no-code interface. And RAG has really made this feasible. So that's the direction we're going to be taking it. So the RAG preparation that we did, I just put the steps here, basics. To prepare the graph for RAG, we added that entity label to all the nodes because what that allows us to do is make the vector index against all of the nodes in total. So you don't have to have separate vector indices that you're searching through for different things. Once you've added those labels, creating the embedding property, again, I had just followed the Memgraph resources to get started, modified a couple things, but nothing major. I think it used a paraphrase sentence transformer model. I think I might have switched that to a mini model instead. You could substitute in whatever model you want to create those embeddings though. And then you add those as a property to all your nodes and create the vector index from that with, again, whatever metric you want, whether it's cosine similarity, Euclidean, etc. So that's the graph prepped for RAG. That's the additional step after we've gotten our data in there. As far as the actual RAG process goes, each time you ask a question, you enter a string. The RAG process that we followed so far, and I actually have I was actually messing this morning with making some little improvements to it, and I didn't want to risk it all in our live demo changing up right beforehand. But I have a lot of ideas on how to modify this RAG process to get the results to be even better. But at the basics, our RAG process starts by getting the key information from the question, and I'll show an example of this in a minute. And then doing a pivot search. I think in the example that I had adopted, there was a pivot search done on all of the key information at once. I found that breaking it down into the different pieces of key information and then doing a pivot search off of that to return relevant nodes for all of the pieces distinctly rather than all of it together, that seemed to work a little bit better for our use. But you do a modified pivot search. Well, I modified the pivot search process to do that to get your relevant nodes back. From there, you have a relevant node or nodes in the database that then you do relevance expansion off of. And so it's just starting at each of those relevant nodes you have identified, making your desired number of hots, returning those paths between the start node, the end node, and that relationship information. And I call these context triplets. I don't know if that's a phrase that's being used more broadly, but it's the start node, end node, relationship data. And that is what is used to give context to the large language model. Again, in this case, we're using Ollama alongside the original question. So an actual example of this, and you'll see this question I'll ask in the little demo thing. But if I ask the question, what projects does Christopher George work on? The key information that's extracted out of it, and I used an Ollama prompt to do this, is Christopher George, the name, and projects, which I think checks out in this situation. So from this key information, I pass my little function that finds all of the relevant nodes. I pass it Christopher George, and it goes through and searches the database for relevant information. I think I might have used a prompt as well. Can't recall off the top of my head. And it does the same for projects. And so it returns nodes that it think might be relevant to that information. And so it did end up finding the employee node with the fake name. Oops, sorry. Jumped ahead there on accident. With the fake name, that's correct. And then a project node with the title containing the word project. I don't know if that's extremely accurate. So again, room for improvement here. From that, though, it takes those couple relevant nodes, and then it does the relevance expansion hops from the employee and project nodes it found to other project and employee nodes. So we used 2 hops and some node limits, fairly arbitrary, still need to test it quite a bit, but it did seem to return ballpark what we were looking for. So I included kind of an example of what the output of this relevant expansion is. As you can see, it shows a start, a relationship, and an end. So that's your context triplet. I know it's very wordy for this slide, but I felt like this was important kind of content to give to see what this actually looks like in practice. From there, this is the kind of context that's provided to the LLM for the relevance expansion contents. And again, alongside that original question of what projects does Christopher George work on. So that is, and we did a little bit of like prompt engineering, of course, to go along with this to get the results in the format we wanted. But that's really an example of what this process looks like behind the scenes. And so now I'll actually show our little chatbot. I have some curated questions, of course, to go over. Along the lines of projects or skills. They're not the same ones that Catherine showed because as I established, RAG process needs some improvement still. So those questions are a little too advanced for this still, but we are going to try our best. And I also think I'm going to pull up the graph actually as well, the graph schema, so we can see that alongside here. Oh, great example of live demos. This was working right before this, but we'll come back to that one in a second. Let me see what it'll cooperate on. Oh no, oh no, oh no. All right, let's see. Let me refresh and see if there's a connection situation going on. Let me try a different question. Okay, thank goodness. I'll go back to those other 2 I tried out and see what we come back with. But asking about skills in the database, as we talked about, we have these extracted skills from the employee over here. And so what it's getting at is basically looking for this relationship, right? I will say, so Tara Myers in this database is me, Madison. That's my fake name in this database. And I definitely have more skills than this. If we tossed in a little ad hoc query real quick, we can see that it did not, in fact, return everything it should have. So not the best results, but again, we will try our best to refine the model to get that. But I think this is just, you know, demonstrating the importance of knowing the data, and we still have to do a lot of testing on this. Have a lot more skills than just creative problem solving and doc2vec, as you can see in here. So need to troubleshoot why that's coming back like it is. Very similarly, we have some basic relationships from the employee to projects that we're hoping it pops up with. The way it's coming back with the answer, and we have it prompting for return it in the specific way. So it's getting at trying to cite the nodes. Okay, again, very nature of LLMs. You never quite get the same thing twice. And we have the temperature set to 0, or close to it at least. So if I'm asking about the projects Christopher George works on, he has mentioned in one of the relationships with the following data. Now, interestingly enough, and this is a good kind of troubleshooting thing that we're going to delve into, but similarly, it doesn't return everything, which is an indication to me maybe it's something about the context window we have. Maybe it's not all of the relevant stuff is being returned. As you can see, there's many more projects that this person has worked on besides just this NLP one that the large language model has returned. So I think those are a couple of good examples, I think, of the types of questions that we're starting to be able to answer with the data structured the way we have. One of the, I think, more interesting questions that doesn't just get at the relationship between nodes, but actually gets at the content. Funny enough, I think you could run this nearly against just the vector search index on the project embeddings. I don't think it really needs a full RAG pipeline, but if the shoe fits, we can answer the question, many questions through this interface instead of specific vector search indices. And again, okay, perfect. So they did pick up that there are human capital related projects going on. I actually picked up this NLP one. We have quite a bit of refinement to do still. There had been one in the past when I asked this question that came up with human research, and we talked about using maybe a little bit of NLP pre-processing in order to help refine the results. So that's just kind of a first glance at some stuff we're testing out, at least. Again, a lot of room for improvement, but being able to root your large language model in the graph data, again, that retrieval augmented generation is really powerful because you can pretty easily double check your answers and create some sort of testing flow to validate the answers that are being returned. Okay, I think that is all I had for the live demo. I had some other questions, but I know waiting for the LLM to return a response isn't the most exciting use of time. I'd rather get to questions. So we'll chat about future work for a second and then take questions. As you guys saw, there's a lot of improvements to still be made. So we want to test and improve how we use large language models, not only for the RAG piece, but also for the information extraction from the unstructured data. Separate project going on that right now. We only have a few resumes in there right now from our team, and we have the full project data set that's available, but we're actually working with the CIO's office to potentially help influence or inform, rather, the type of data they could collect to make applications like this more useful and be able to answer more questions about projects across the agency. So would love to expand the data sources in that way. Again, as I mentioned, refining the RAG process. We have some really awesome interns on our team doing some parallel research on how we could leverage Model Context Protocol, so MCP, in this project and others. And I see potential to add that in to this process and use some tools to maybe direct the large language model to answer different questions about the graph in different ways, using different approaches, whether that's pivot search, relevance expansion, maybe tailoring it to use a specific vector search index instead of the general one across the whole database. as well as maybe delving into having it actually generate Cypher to help with any of those steps. So lots of room for opportunities there. And then, of course, as we think about actually being able to answer questions and put this in the hands of people who would use it, productionizing it. So there's a lot to be done on this, which is exciting. But I want to hear from our audience and see what kind of questions we might have.
Thank you, Madison. Thank you, Catherine. Thank you, David. This was really nice presentation. And let me just move the stage around. Okay. So yeah, I mean, the demo was great. No worries, Madison. It's up to LLM. It's its fault, so no worries about that. You cannot do anything about it. Okay, we have a lot of questions, so I will go like one by one. So the first questions were more related to the first part that was related to queries. But first, in the beginning, you talked about your older project with entity recognition, and I think that we had a question related to that, like how to get from unstructured text to the actual keyword classification. So were you using LLMs to do that kind of classification, or what was the process there?
So if we're talking about pre-LLMs, that was custom named entity recognition. So there's some spacey models that are out around named entity recognition. It's been a few years since I've worked on that. Wow, time flies. So I don't know specifically what we used at the time, but I know that it required you had to provide a training data set that had the either text or the questions labeled with the tags themselves. And that is a very manual process. So I am sure there are cases where that is appropriate. For us, it was not, because it was going to require a lot of generation of manual tagging and then having subject matter experts or just data experts validate that. So as we've gotten into the large language model helping us extract that information, that's taken a little bit different of an approach.
Yeah, definitely. It's a totally different story with LLMs nowadays. So the other question is, did you know the graph relations a priori, or did you define them as you go? So what was the process of actually defining these relationships to get them into a graph database from the text?
Is it specific for skills or projects?
Yeah, it's not specific. Maybe it's just in general, like how to even translate two relations in a graph.
Yeah, I think part of it, I mean, David had really started this project before I came on as an intern, so I'm sure he can talk to it. From my point of view, it's kind of just the intuitive connection, how people are connected to their different attributes and work. I know that there is an element of it, though, considering how do you model the data in a graph to answer questions the way you need to, and leveraging the different algorithms that are available. So, David?
So let me, and I'll pick up a little bit on that. When we first started, one of the beauties of knowledge graphs when you use them, or graph database in general, is you don't necessarily need to know the schema behind the data before you start, like you do in a traditional relational database management system. So it's good to understand your data model, have an idea of what we did. So we sit down and think, and literally I draw it out on a whiteboard. Okay, I know the person, and what do they have? They have a piece of knowledge, they have some skills, they have some tasks, they have various different things that we can relate back to. How can we find those nodes within the information that we have? So you have an idea of those known relationships, but then as you start exploring with the graph, you can start finding those latent relationships that are there, and you can easily add them back into the graph through how your development and through your query structure. Uh, so without having to change everything like you would in a traditional SQL. So again, that just gives us an opportunity to look at the relationships and figure out how do we add more data to this knowledge graph to do that. So we started off with occupations way back when, looking at the occupations and the elements that make up occupation, knowledge, skills, tasks, abilities, technology. Well, individuals or employees have that same information, and also training. Your curriculums have that same type of information. So we figured out how to relate all three of those together. So it's really, you can start off with a data model, but it'll expand based on what you learn about the data as you go along.
I think
I think that makes sense. Yeah.
I think the only relationship that we formed after we created, added all the data in, was like the similarity relationships between projects and those types of things. So that's already ported in there, and then those relationship enrichments we want to add based on the data that's already in there. That's the only thing I can think of that would be on the go.
Yeah, I think that's the good point you made, because there was a question related to that, like how do you even have these relationships related to cosine similarity and those similarities? So I think that you basically create it afterwards, right?
Yep. It's just iterating through the different. I think technically it was call all your project nodes and return the descriptions, and then iterate through those, and match them up and compare the embeddings between the two, and create a relationship of the cosine similarities above a certain threshold. That's what we found worked for our application. I hadn't really experimented a whole lot if I could do that within a vector search index. I don't think that's really what it's for. But again, I don't think that's required for what we were wanting to do. It's just nice to have. So.
And you did mention when you jumped over to the RAG part of the presentation, you did mention using I don't know, sentence transformer or other model to generate embeddings. So did you end up storing them in Memgraph to do the similarity search?
Yes. So before I actually created the RAG component of it, what I started off with was simply just doing the vector search index on the project description embeddings by themselves. And so that's kind of what I used at first, at least. Now, when it gets into the RAG component, it does the embeddings over all of the properties and all the nodes, not just the specific description embedding for the projects. So again, I think there might be some room to combine that more tailored approach within a RAG pipeline, actually, depending on how you wanted to approach it. But that's how we went about the similarity search to begin with.
Yeah, that makes sense. And there were some questions about re-ranking. I think there was at least one. I'm highlighting now one. But there were a lot of questions were you doing anything with the re-ranking. So you get the results back from the vector search. Are you doing anything additional to kind of improve the answers?
No, not yet. That's not something that I've tested out yet and incorporated.
And we have
but definitely
we have tested re-ranking in other situations and other projects we're working on, but not necessarily here. It is part of our pipeline in some of our other more advanced RAG capabilities we're using, but those are more for other types of capabilities, not the Memgraph capability right now. Eventually, we'll look at implementing something like a re-ranker within here as we get further along with this project. It's better to start simple, so you get used to that,
definitely.
and try to add more things to it.
Yeah, and as Madison said, it was a really good point. I think quality of the underlying data is important. I remember that because we keep saying that. And regarding the data model, and it's not a problem if it's different from the start. You can change it if you notice that LLM is either going to give you better answers or your queries are going to be faster. So I encourage everyone to tweak their schema to change that kind of stuff, because it can help their application in the end.
Absolutely. One of the things that I'd really like to see is actually for the projects, not just having the descriptions, but actually having specific components about the project. For instance, the problem statement, the project goal, maybe tools and technologies used of properties on it, or even splitting those out into nodes that connect to the projects, because I think that at that point, your RAG is going to work better because of the specificity within that, but also you can start to connect it to other components of your graph as well. Same for skills off of people, actually being able to categorize those as this is a technology, it's a tool, it's a soft skill, it's those types of things. So we just haven't, we have gotten into that in the separate project. We just hadn't incorporated that into this yet.
Yeah, and when talking about the data model, we have a question. Have you considered including employees' goals for acquiring skills and preferred scope of projects into the data set?
Yeah, I can speak on that a little bit. As Maddie mentioned on the previous projects we worked on, which we called KSAT, knowledge, skills, abilities, tasks, and technologies. We looked at all different types of elements that can be incorporated into not only an occupation, but an individual and the different things that they know. Part of that is to also understand, and I think there was another question there about training or something to that degree of skills somebody might like to learn, which kind of fits into this employee goals. As we start to expand that knowledge graph with the occupation information to the employee information to the training available to the projects they're working on, we can start developing training paths, career paths, look at skill gaps and trying to figure those types of questions out. So there's a lot of things we can do. And for sake of time, there is a presentation we have done on that particular project and other things. You can definitely do a search for it, or I can share that later on. I've done several presentations on how that could be, how knowledge graphs can be used to answer those types of questions.
Yeah, thank you. A lot of things to do, a lot of things you've done previously, and a lot of things to incorporate in the future, definitely. And we have another question on the data model. So are you also storing data attributes and relations? So when I just like proficiency level of related skills or years of experience. So are you using that in your traversals?
We do have some of those attributes on the relations, not as in-depth as we would like yet. We still need to do some experimentation and testing on how well that works, like the quantification of years of experience in a certain job or with a skill. So it's not yet added into the relevance traversal. I mean, as far as the RAG goes, it considers relationship properties in the context triplet. And so it's being considered within that, but it's not a primary thing that's being focused on yet. So I would like to explore that, the use of that a lot more. I think it can be really powerful.
Yeah, definitely. And we have we have a lot of questions, guys, so this is great. A lot of people interested in what you have been doing. So we have a bit of different questions to switch it up now. So what made you choose Memgraph and AWS over other setups? So if you consider Neo4j and Google Cloud and so on. So what is your comment on that?
So as I mentioned earlier, I've been at this for well over 10 years, and I've looked at various different graph databases from that time. I was using Neo4j when it was a command line interface, back in 2015. So I've gone through a lot of those things, and Neo4j was, let me back up. I prefer label property graphs over RDF, so just to make sure people understand that. So that naturally made me gravitate more towards Neo4j as the primary one at that time. The biggest thing is, with Neo4j, it's very costly for me. Yeah, I'm gonna be quite upfront, and I've told them this, the Neo team, the same thing. I can't afford that within my current environment, what I have to do. A few years ago, I came across looking around and I found Memgraph. Memgraph uses Cypher, just like Neo4j. Memgraph doesn't Python, unlike Neo4j was just Java. So there was a lot of benefits in saying, okay, I can utilize the same tool without having to relearn a whole lot because we've done a lot of work with the Neo4j. And then they showed me the cost. That kind of sold me at the time for us to be able to do that, and it does everything we've done in label property graph. So we were able to pivot over to a tool that was more cost effective for us, and we did not have to have a huge learning curve because we were already using the same capabilities that we already learned. And my team is half Python, half R. So the Python side could easily go in there and replicate what we needed to do. So it was more about ease of transition as well as cost around that.
And I can talk a little bit about the AWS piece because I saw another question come in. We are very concerned about where our data goes and what information is on what resource. Our AWS environment is specifically made for the government agency. So we are in commercial, but it's on its own separate. We aren't the people who manage the AWS. That's one of the reasons we use AWS, actually. How we have this deployed our agency is there's a specific team that oversees its cloud engineers and cybersecurity experts who oversee the actual deployment of this AWS environment for multiple tenants, of which we are one. So we have our own little AWS account as a tenant within this bigger infrastructure. Now we are on our private agency network. We have all control over our resources. Our data does not leave any of the resources of the agency. So that is not being shared anywhere else. And that's kind of a reason we chose to use AWS, is because the way it's deployed our agency makes it where we have to manage some things like our servers, and data storage, but the way that it's deployed just makes it more easily usable for our team of data scientists. So
I can also jump in
Yeah.
here. Part of this project, we had the opportunity to work with the Memgraph team, and they actually were able to create an enhancement so that now, where previously you were only able to use a public S3 bucket to connect into Memgraph, we were able to successfully complete that enhancement. So now we're actually using a private S3 bucket in addition to the very private AWS server that Maddie was just talking about. Yeah, I can hear now. But so that was a fantastic enhancement. We were super excited to see that addition to the project as well.
Yeah, definitely privacy in those kind of companies and with that kind of data is really important with the databases. So do you have another minute to go over a couple of more questions? Okay. Sorry for making it longer, but I see a lot of interest here. So yeah, this is a good one regarding the LLMs that have been talked about these days a lot. So what is the point of using them? So is it just for the natural language interface? So, I mean, the user says, sorry, I missed the first part, but I would say this is still a good question. Like, what is the main goal? Why LLMs? Why natural language?
I can kick it off, Maddie, if you don't mind. So
go
one of
for
the
it.
reasons why we are pursuing that RAG LLM interface post the manual queries is because there's lots of people that are capable of doing the backend analysis, of standing up the backend people graph and doing that visually for themselves. But the direction potentially we are seeing things go is people are also going to want access to this through a large language model, through that fast, high level chatbot where they can go and while they might have the capabilities even to do this analysis and use a tool, they don't have the time. And so that is one of the reasons that we are exploring that, is to kind of expand who has access to this information through our team. And it also just kind of growing as times are changing with where our reports are going, what they're looking like, and what we're actually able to do with the data.
And just to me to add to this, I mean, what's the point of using LLMs? I mean, it's the future of what's going on right now, and it's not more about using LLMs right now just for this particular project. It's how do we use LLMs into our workplace? How do we get it into our workflow? How do we use LLMs to make it easier for us to do our things? Some of the other work we're doing around LLMs, while we may use either a vector database or a graph database in the back end to store some of the information, it's more about how do I shorten the time it takes for our customers, our end users, to be able to do their work uh, and still get good information, good results. How do I help them summarize things? How do I help them create presentations? How do we help them analyze data on the fly? And how do I get them to quit asking me very simple questions, just like how many people don't work at NASA at this point? Go ask an LLM how many people is it. It should be able to
Yeah.
tell you that. And those are the types of things we're trying to speed up, because then it frees up people, on my team like Madison and Catherine, to be able to do the real important work and the real deep dive into some of these technical things.
And I think specifically building off of that, how do LLMs save us time? I go back to, I spent a semester working on a custom named entity recognition model to extract those pieces of information like node labels, node properties, relationship types out of a sentence of a question to see if I could convert it into a Cypher query. A large language model has been trained on way more data than I could ever give it, first of all, and I don't have to manually tag all of it and train it. Yeah, I have to validate it. I still have to do the testing piece, and that's really important. However, the time that it takes to reduce development, even, I mean, and that's separate from what David was talking about giving the data scientists back some of their time by helping other people, empowering them by answering their own questions. But that to me is like, why do we use LLMs? Because I don't have to manually tag resumes anymore. That's why. So, but of course,
Good
there's the
enough
other part
reason.
of it. Yeah, right. But there's the other part of it too, of you have this retrieval augmented generation. Like, why use an LLM in that pipeline? I've been playing around with different things, and you don't technically need to. Like, you could do your finding you could do all of that with some NLP packages. You could do that. The things that I was coming up against, at least, I would like it to look at the question and figure out what is the relevant information from this based on my graph schema. How do I answer this question? Make me a Cypher query to do my relevance expansion. Those are things, again, that the amount of underlying NLP manual programming and tagging of things you would have to do to make that work, it can't be done in a week and thrown together and tested and at least coming up with semi-decent results. So I think that's why I use LLMs in this project. It's a huge time saver. So
yeah, and related to that, we have a question of what process specifically or part of NASA would you say have increased productivity and efficiency with your solution, or at least what's the goal?
So we haven't put this into production yet. So this is just being tested upon. I will say from my point of view, as someone who works on AI and ML projects, I'm specifically excited about incorporating project data into here because if I'm working on a natural language analysis, trying to create cipher queries, our agency is so big. We have so many different types of work going on. Surely someone else is working on this. And we find this out on occasion through our little AI ML community of practices and those types of groups or just knowing people working on similar stuff. But how do you make that accessible to everyone? Like someone new here coming up with a new project idea, or if you wanted to create kind of a group of people to collaborate on a very similar problem, they're all working on distinctly. I mean, that's what I think has application for. Again, not actively being used. This is being developed currently and seeing how we could leverage it in that way, though. I know Andrew, or not Andrew, sorry, David and Catherine have ideas on this as well.
So as Maddie said, we haven't put this into production yet, but what I'm most excited about the potential for this project and where we're seeing it going is to just gain a really comprehensive understanding of who is the workforce. Where do we have opportunities to improve efficiency? Because like we have untapped potential and skills that are not working on projects that could be maximizing their skills. Where do we have opportunity for upskilling? So as we grow and as times change and technology develops, how do we have to maybe train some people, and what specifically do we have to train them on? Which only, like, if that's only a good thing for everybody, because then everybody's baseline understanding is improving. I'm excited to understand because part of my specialty is workforce analysis. So understanding how we maximize our workforce, how we understand what projects are going on, kind of like Maddie said, duplicative work. I'm super excited about that. I'm excited to see knowledge transfer. We have a lot of really smart people that work around us, and not everybody has figured out like how to share all of their fantastic knowledge. And so having some sort of database that we understand who was working on what project, what the important pieces of information that need to be made available for that project is, where those are being stored. Like the potential for this project is truly limitless at this point. When we were talking about our categories, we picked 3 out of probably 100 we could have pursued.
Yeah, thank you both for answering this one. It's a really interesting area, definitely for the productivity of I would say like not only your team but the others as well. And we'll see what the future holds. Maybe to go or just to go back to the questions that were more related to the data and how do you deal with data. So there were some questions around duplications and ambiguity of data. So how do you deal with duplications? Like if you have skill naming and in every CV, it's maybe a bit different. So for example, JavaScript, JS, and how do you create such nodes within a graph? What is your strategy there? Do you keep an array of synonyms in one node, or what do you do there? Do you have any solution for that currently?
That's an excellent question to actually try to figure out how you do some of that disambiguation through that. Part of it is, I think, that the large language model can help to some degree because they should understand, when somebody says JavaScript or somebody within the context of what they're writing may say JS. Or something like that. Generally, it can pick up those nuances. But part of it is also trying to figure out the right way of creating some type of context for the LLM. So provide within your RAG environment, again, we just started with a very simple RAG environment. There's so many other things you can do with that as you start building across tools and functions and agents and workflows across that to be able to provide. So one of the things we've started looking at is developing context-specific assistance using large language models that could be supported by graph databases as well as other capabilities in for example, right now we've created a bunch of a pipeline that's specifically on the R programming language for people to just that want to learn how to do that around a particular set of the R programming language, the tidyverse. So being able to use that information, that assistant to ask questions around that will always give you back. So whether I say tidyverse or dplyr or something like that, it's going to know what I'm talking about. Very similarly, we can do things like that around the type of deduplications we're trying to avoid. Within that, feed that to the LLM and says, when you hear this, this is what you need to talk about. So it has a lot to do with prompt engineering to a degree and context awareness for the large language model.
I would say that previously, before large language models and a RAG pipeline, I would have been much more concerned about deduplication. But as David said, there's a lot that large language models just kind of get. That being said, whenever we're evaluating the extraction from resumes, like the skill extraction from resumes and seeing how accurate it is, there is a little bit of a semantic incorporation that we do on the accuracy metric to make sure that those types of similarities are being considered. So. Oh, Katerina, can't hear you.
Sorry, yeah, I muted myself. Do you hear me now? Yeah. I had one last question that we have is regarding the scale. So now you have some test data that you loaded into Memgraph regarding CVs. What kind of scale would you expect to have? What do you think in terms of nodes and relationships? How large should that graph be in your case? What's the volume of data?
Great question.
That's hard. That is hard to kind of anticipate. I think when we were looking at our KSAT database, which had everything in there from skills, cross occupation employees, training, things like that. Maddie, remind me, that was probably no more than 300. I'm trying to. No, it wasn't even that much.
Yeah, I'm looking at the stats for our full database right now, and we have about 27,000 nodes and about 230,000 edges. And this is definitely not exhaustive. As I mentioned,
Right.
we still need to add more resumes, more skills, more projects. So I imagine scaling up from there. We have about 18,000 employee nodes in there, give or take 1,000. And this is just some of our more recent data. So that's gonna always be at least 20,000 and just the people.
And that alone in itself is a very small graph database when you think about it in terms. But I think our last one, we probably were looking at least 500,000 nodes and 1.5 million to maybe 2 million relationships across that. And it handled it very well, quite easily. And again, to me, that's still a very small graph when you think about the other things you can do with it.
Yeah. In terms of graphs, definitely, it can be a lot larger. It can get a lot larger, but yeah, this is for now, a really good size to handle everything properly. So yeah. I think that's it. If anyone has any more questions, feel free to drop it on Discord on our server, community server, where we hang out. We can forward them to David, Madison, and Catherine to answer them. And there will be a recording available. There were a lot of questions about this as well. I guess people would like to rewatch your presentation. Once again, thank you, David, Catherine, Madison, for joining this Memgraph community call, for agreeing to presenting and for showcasing your great work. I'm looking forward to the future improvements. And I guess once you do that, you can join me again and tell me more about it. Until then, until the next community call, I guess I see you all then. And that's it. Do you want to say anything else? Three of you?
Thank you. Just thank you for everybody
so
for your time.
Yeah.
No problem. Thank you all. Bye, everyone.
Bye.